In this lecture, we are going to discuss the properties of Z transform. Now, firstly, in this, we will be discussing linearity property, then time reversal property, and then time shifting property. Now, if we look into the linearity property, if we are given x1n and we have its Z transform as x1z, and if we have x2n and its Z transform is given as x2z, then if I have the next signal, that is xn, and it is given to me as the weighted sum of x1 and x2n. Now these are the weights, basically a and b. Now these are the weights and these are basically the constants. So xn is given to us as a x1n plus b x2n. Then its Z transform will be given as a x1z plus b x2z. Now this can be easily seen by a numerical. Now if we determine the Z transform of xn is equal to cos omega naught n into un, or this question can be either framed as xn is equal to cos omega naught n for n greater than equal to 0. Now both the cases are same, as this un is also valid only for n is equal to n greater than equal to 0, because at this juncture the value of un will be 1, otherwise the value is 0. So we can write that cos omega naught n in terms of the Euler identity theorem. We can say that cos omega naught n is equal to 1 by 2 e to the power j omega naught n plus e to the power minus j omega naught n. So if I take this 1 by 2 inside, then I have 1 by 2 e to the power j omega naught n plus 1 by 2 into e to the power minus j omega naught n un. So un was there, so we will be taking the un with us. So this xn is given to us like this. Now if we relate this to this expression, we can see that this a and b will be equal to 1 by 2. Both will be having the same value. And this x1n will be e to the power j omega naught n into un. And this x2n will be e to the power minus j omega naught n into un. And as we know that any exponential value alpha to the power n multiplied with un have a Z transform, that is z upon z minus alpha, where mod z should be greater than mod alpha. Now if I have x1n that is equal to e to the power j omega naught n un, this alpha can be e to the power j omega naught. If this alpha is equal to e to the power j omega naught, then its Z transform will be z upon z minus e to the power j omega naught, where mod z, as we have mentioned, should be greater than mod alpha. So mod z over here should be greater than mod of e to the power j omega naught. Now similarly, my x2n is e to the power minus j omega naught whole to the power n into un. So similarly, instead of this alpha, I can put that this alpha is nothing but e to the power minus j omega naught. So my x2z will result in z upon z minus e to the power minus j omega naught, where the value of mod z should be greater than mod of e to the power minus j omega naught. Now if I put these values, if I know that this xn has a value of xz, where xz is ax1z plus bx2z, so I will be having xz as half into z upon z minus e to the power j omega naught plus z upon z minus e to the power minus j omega naught. Now if we want to check the ROC, now we have mentioned that mod of z should be greater than e to the power j omega naught. Now mod value of this e to the power j omega naught will be nothing but root of cos square omega naught plus sin square omega naught. Now which ultimately gives us 1, and the root of 1 will give us 1 only. So here we can see that in this ROC we have this radius equal to 1, and since mod z is greater in both the cases, and for both the cases this mod z should be greater than e to the power minus j omega naught, its value will be 1 as well. So the radius will be 1 and my ROC will be the entire z plane outside this radius. So this will be my ROC of this signal. Next we will check out time reversal property. Now for time reversal property, if I have xn and its z transform is given as xz and it is having an ROC that alpha 1 is less than mod z is less than R2. So if there is a reversal in time, that is x of minus n is there, then its z transform will be x of z inverse, and the ROC will be 1 upon R2 less than mod z is less than 1 upon R1. So this can be very well understood by an example. So here is the example that obtain the z transform of the discrete time signal xn is equal to u of minus n. Now we already know that un has a z transform z upon z minus 1, where the value of mod z should be greater than 1. Now if I use the time reversal property and find the value of u of minus n, it can be very easily found by using this property. Instead, wherever there is z, I can put z inverse there. So I mention z inverse here instead of this z, and instead of this z I mention z inverse over here. Now after taking the LCMs and all the values, and here for the ROC as well, we will be mentioning z inverse over here. So after taking all the things, after taking the LCM and all the necessary steps, we will obtain that u of minus n will be having a z transform of 1 upon 1 minus z, where the ROC is mod z less than 1. So we can see from this ROC diagram, or we can see from this z plane, that the ROC is inside this unit circle. That since this value is less than 1, so this radius of this circle is 1, and it is the ROC is consisting of the values inside this unit circle. Now next we will be checking time shifting property. Now for this time shifting property, we have, if we have xn, then its z transform will be xz, and if we have xn minus n naught, then its z transform will be z to the power minus n naught into xz. Now this ROC of this z to the power minus n naught xz will be same as that of xz, except for z is equal to 0 if n naught is greater than equal to 0, and z is equal to infinity if n naught is less than 0. So the ROC will be more or less the same value. Now to understand it, we have this question that by applying the time shifting property, determine the z transform of the signal xz is equal to z inverse upon 1 minus 3z inverse. Now here we can see that this expression over here is consisting of z inverse, which is divided by 1 minus 3z inverse. So we can take this z inverse outside and we can say that the remaining part, that is 1 upon 1 minus 3z inverse, is nothing but another z transform, that is x1z. So we can find the value of this x1z. We can find the inverse of this x1z, and accordingly we can see that the inverse of this relationship, if I look, or if I take the LCM, that will be z upon z minus 3. So it will be corresponding to 3 to the power n into un. Okay, so this xn will be the z inverse of this x1z, this 3 to the power n un. Now here we have mentioned z to the power minus 1. So if I relate this to this property over here, this n naught will be nothing but 1. Okay, so if I take this inverse, this value of xn will be equal to, since it is mentioned xn minus n naught, so it will be, we will be subtracting 1 from here and 1 from here, so it will be yielding me xn is equal to 3 to the power n minus 1 into u n minus 1. Now here is another example which you can solve on your own. Now here the numerator and the denominator are having the same values, so what you can do is, first you can divide the numerator from the denominator, and then subsequently you can utilize the time shifting property and you can get the answer. Thank you.